Differentiation Exercise 1. This is an exercise on the power rule for differentiation. Given that y equals k x to the n, then the differential of y, dy by dx, is equal to kn x to the power n minus 1. If you pause the video at this point, you can have a go at the questions, and then when you're done, you can restart the video and I'll go through the answers. Okay, let's see how they're done. Well, in question 1a, you're given y equals 3x squared. Now the power 2 is multiplied at the front and reduced by 1 as a power. So dy by dx is 2 times 3x to the power 1, which is dy by dx equals 6x. In question b, you're given y is equal to 5x cubed. Now the power 3 is multiplied at the front and reduced by 1 as a power. So dy by dx is 3 times 5x squared. Well, that simplifies to 15x squared. In part C, we have y equals 7x. Now, that is y equals 7x to the power 1, which differentiates to give 1 times 7x to the power 0, or just 7. In part D, we've got y equals 23. Now, whenever you differentiate a constant, you just get 0. So dy by dx is equal to 0. Now, in part E, we've got y equals 2x squared plus 4x cubed. Now, to differentiate that, we just differentiate each of the terms in turn. So dy by dx is equal to, now when you differentiate 2x squared, the 2 comes to the front and is reduced to 1 as a power. So that's 2 times 2x to the power 1. And for the cube, the 3 comes to the front and the cube is reduced to power 2. So we have plus 3 times 4x squared. Now that simplifies to dy by dx is 4x plus 12x squared. In question F, we have y equals 3x squared plus 2x plus 6. So when we differentiate, we get dy by dx equals, now the first term, power 2 comes to the front and is reduced to power 1. So that's 2 times 3x to the power 1. In the second term, 2x differentiates to 2, and the number term at the end disappears. So we're left with 6x plus 2. In question G, we've got y equals 4x to the power 5 minus 3x cubed minus 23. Now when we differentiate, dy by dx is equal to, now in the first term the 5 comes to the front and is reduced as a power by 1. So that's 5 times 4x to the 4. In the second term, the cube, the 3 is brought to the front and it's reduced to a squared. So you end up with minus 3 times 3x squared. And that simplifies to dy by dx is 20x to the 4th minus 9x squared. And in part H, before we can differentiate, we have to expand the brackets. So expanding the brackets, we have y equals, first pair gives x squared, outer pair gives x times 5, which is 5x, inner pair gives minus 3 times x, minus 3x, and the last pair is minus 3 times plus 5, which is minus 15. Now that simplifies to y equals x squared plus 2x minus 15. So dy by dx equals, now x squared becomes 2 at the front, x to the 1, that's 2x, and plus 2x differentiates just to give 2, the number at the end disappears. So dy by dx is 2x plus 2. Now in part I, again we've got a bracket, so we have to get rid of the brackets first. We have y equals 3x into 2x squared minus 3x plus 5. So expanding the brackets, you have y equals 6x cubed minus 9x squared plus 15x. Now to differentiate, we have dy by dx equals, and when we differentiate the first term, the cubed 3 comes to the front and is reduced to power 2. So we have 3 times 6x squared. In the second term, minus 9x squared, the 2 comes to the front and it's reduced to power 1. So that gives you minus 2 times 9x to the 1, or just x. And the 15x is reduced just to 15. So, simplifying that down, we have dy by dx equals 18x squared minus 18x plus 15. Now in question J, we have y equals x squared plus 1 times x minus 3. The first thing we must do is get rid of the brackets. So y equals, now the first term is x squared times x, which is x cubed. The outer pair is minus 3x squared. The inner pair is plus 1x. And the last pair is minus 3. Now to differentiate, x cubed becomes 3x squared. Minus 3x squared becomes minus 2 times 3x. And x, or 1x, just becomes 1. So that simplifies to dy by dx equals 3x squared minus 6x plus 1. In question 2, we're asked to differentiate y equals x cubed minus 5x squared plus 3x plus 2. Now to do this, we've got dy by dx is 3 times x squared minus 2 times 5x to the power 1 plus 3. So that's 3x squared minus 10x plus 3. In part 2, we're asked to find the gradient of the tangent at x equals 2. So we substitute x equals 2 in dy by dx equals 3x squared minus 10x plus 3. So that's 3 times 2 squared minus 10 times 2 plus 3, or 12 minus 20 plus 3, which is minus 5. So the gradient at x equals 2 is minus 5. Now in part 3, we're asked to find the equation of the tangent at x equals 2. Now the first thing we need to do is find the point on the curve when x is equal to 2. In other words, we need to find the y coordinate. Now y is equal to x cubed minus 5x squared plus 3x plus 2. So that's 2 cubed minus 5 times 2 squared plus 3 times 2 plus 2, which is 8 minus 20 plus 6 plus 2, or minus 4. So the tangent passes through the point 2 minus 4 with gradient minus 5. So using the equation of the line y minus y1 equals m into x minus x1, we've got x1 is 2, y1 is minus 4, and the gradient is minus 5. So y take away minus 4 equals minus 5 into x minus 2. Or y plus 4 equals minus 5x plus 10, or y equals minus 5x plus 6. So the equation of the tangent can be written y plus 5x equals 6. Now in part 4, we're asked to find where the tangent crosses the y-axis. Well, the tangent is y plus 5x equals 6, and we want to know the value of y when x is 0. If x equals 0, then y plus 5 times 0 equals 6, so y equals 6. So the tangent crosses the y-axis when y is equal to 6. Now we can represent all of this on a graph. If we draw out suitable axes, we can then draw the curve of the graph. We can mark the point 2 minus 4 and draw the tangent at that point. And we can see the tangent crosses the y-axis at y equals 6. Now in question 3, we're asked to differentiate y equals 3x squared minus 2x plus 3. Now we have y equals 3x squared minus 2x plus 3. When we differentiate 3x squared, the 2 comes to the front, leaving 2 times 3x to the power 1, or 2 times 3x. And when we differentiate minus 2x, that just becomes minus 2. So dy by dx is equal to 2 times 3x minus 2, or dy by dx equals 6x minus 2. In part 2, we're asked to find the gradient of the normal when x equals 1. Now the normal is at right angles to the tangent, so we need to find the gradient of the tangent when x is 1, and that's dy by dx. So that's equal to 6 times 1 minus 2, which is equal to 4. Now to find the gradient of the normal, we take the gradient of the tangent, change the sign in front of it, and take its reciprocal. So we start with 4, and that becomes minus 1/4. The gradient of the normal is minus 1/4. In part 3, we're asked to find the equation of the normal at x equals 1. So, substituting x equals 1 into the equation, 3x squared minus 2x plus 3, we can get y. So, y is equal to 3 times 1 squared minus 2 times 1 plus 3, which equals 3 minus 2 plus 3, which is 4. So, we have the equation of the line y minus y1 equals m into x minus x1, with x1 equal to 1, y1 equal to 4, and the gradient m equal to minus 1/4. So substituting those in, we have y minus 4 equals minus 1/4 into x minus 1. If we multiply all the way through by 4, 4 into y minus 4 equals minus 1 into x minus 1. So 4y minus 16 equals minus 1x plus 1, or 4y equals minus x plus 17. So we can write the equation of the normal as 4y plus x equals 17. Now in part 4 we have to find the point the normal intersects the y-axis. Well, it intersects the y-axis when x is equal to 0. And so that gives us 4y plus 0 equals 17, or y equals 17 over 4. So the point on the y-axis is 0, 4 and 1/4. Now we can see this on a graph. If we draw out some axes on the graph grid and then draw the curve, we can draw the tangent at 1, 4, and then we can draw the normal at right angles to the tangent, and we see it crosses the y-axis at 0, 4.25.